In previous video, we have discussed sequence alignment, why we need to compare two sequences, and qualitative sequence alignment dot plot. In this video, we will focus on quantitative sequence alignment and especially global alignment. So, global alignment is dynamic programming, and dynamic programming is a method that determines optimal alignment by matching two sequences for all possible pairs of characters between the two sequences. It is fundamentally similar to the dot matrix method in that it also creates a two-dimensional alignment grid. However, it finds alignment in a more quantitative way by converting a dot matrix into a scoring matrix to account for matches and mismatches between sequences. By searching for the set of highest score in the matrix, the best alignment can be accurately obtained. In global alignment, we align sequences end to end, and in local alignment, we align only sequence with the high similarity. Global alignment is also known as a Needleman-Wunsch algorithm, and it is an alignment algorithm used in bioinformatics to align protein or nucleotide sequences. It was one of the first applications of dynamic programming to compare biological sequences. The algorithm was developed by Saul B. Needleman and Christian D. Wunsch, and it is published in 1970. The algorithm essentially divides a large problem into a series of smaller problems, and it uses the solution to smaller problems to find an optimal solution to the larger problems, like this. The algorithm is widely used for optimal global alignment, particularly when the quality of the global alignment is of utmost importance. The algorithm assigns a score to every possible alignment, and the purpose of the alignment is to find all possible alignments having the highest score. For example, we have these two sequences T and S, AGT and AAA and T. We need to devise a scoring scheme. For match we have 1, for mismatch -1, and for gap -2. We have 3 steps in global alignment in this dynamic programming method. First one is initialization of the matrix. We initialize the matrix with the gaps in incremental order. Then matrix filling, and last one is traceback. After tracing back, we align these sequences. We have this formula Eij, and maximum out of these three, Ti -1, J-1 plus scoring the score of match or mismatch, and Ti -1 J plus score of gap, and Ti and J-1 plus score of the gap. So this Tij is actually the address of this box. Okay, we if we have to fill this box, there can be 3 values. One from the upper box, the value of upper box plus gap penalty, and or the value of this left box plus gap penalty, or the value of this diagonal box plus match or mismatch scores. You will face this situation while filling every cell of your matrix. Like this, you have to fill this box. There can be 3 values, either from upper box or from left or from diagonal. Maximum out of these 3. This box is I-1, J-1, this one, plus score of match or mismatch. This one is I-1 and J plus score of gap, and this one is I and j minus 1 plus score of gap. Okay, the first step is initialize the matrix. We have a 2D matrix. We place the sequence in a row and column. We will create a matrix with one extra row and an extra column like here, and we initialize this matrix with the gap in incremental order. For example, we have here 0 and then minus 2, and we add minus 2 to this gap, and it becomes minus 4. We place minus 4 here, then we add minus 2 to minus 4, and this will be minus 6 here. In this fashion, there will be minus 2, minus 4, minus 6 and minus 8 like this. Okay, you need to remember this approach while filling this matrix, because you will have to face this in every box. So here we need to fill this box, and we have these three values here: minus 2 in upper box, minus 2 in left, and 0 here. So there is a match A and A. So first we add a match score here: 0 plus 1, it becomes 1. Then minus 2 plus minus 2, it becomes minus 4, and minus 2 plus minus 2, it becomes minus 4. So 1 is the maximum out of these three boxes. We place 1 here. Now we move next box. It is a mismatch. So minus 2 plus minus 1, minus 3, minus 4 plus minus 2, it is minus 6, and 1 plus minus 2, the value of gap here, 1 plus the value of gap, which is minus 2, so it becomes minus 1. So the minus 1 is maximum, we place here. In this fashion, we fill the whole matrix. So the last box, there is a match T and T. First we add match score to this diagonal box. Minus 2 plus 1 becomes minus 1. Minus 4 plus the gap score, which is minus 2, so this becomes minus 6. And minus 1 plus gap score, it becomes minus 3. So minus 1 is the maximum out of these three boxes, and it is coming from this diagonal box. Now we will start trace backing. In Traceback, we need to look from which box this value is coming. Like either it is coming from upper box or diagonal box or the left box. Like in this case, this value is coming from minus 2. Like we have a match T and T here, and if we add, this becomes minus 3, this becomes minus 6, and this becomes 1. If we add mismatch score, which is match score, which is 1, so it becomes minus 1. So the value is coming from diagonal box, so we place a back arrow here. The value, so we move here, it is a mismatch. Okay, and if we add minus 2 to this gap, the value of gap to this 0, so it becomes minus 2. And if we add value of mismatch, minus 1 plus minus 1, it becomes minus 2. So this minus 2 is coming from this box, upper box, and this diagonal box. So we place two arrows here, and in this fashion we place arrows to all boxes from where the values are coming, like this. Okay. And this value is coming from this box, and this value is coming from upper box and this diagonal box. So there are total 3 alignments. So in first alignment, we place T and T in front of each other, like in this fashion, T and T. Now we move here. So the values are coming from two boxes. First we will follow this path. We move here, then here, then here, then here. If the value is coming from the upper box, we add a gap to that sequence like this. This is AGT, this sequence, and we add a gap here, and we align this gap with this A. Now we move here. Now all values are coming from diagonal, so we place them as it is. Like we're here, we align, it is a mismatch, we align A and G. We move here, then we align A and A like this. Now in next path, we move here, so we align T and T. Then we as the value is coming from diagonal. If the value is coming from diagonal, we align those two residues or two nucleotide bases. And if the value is coming from upper box, we add a gap to that sequence and align that gap with the residue or the base in the other sequence. Like in this case, we add a gap here and we align it with that base. So we move here, we align T and T, then we are here. Now the value is coming from diagonal, we place A and G in front of each other. Now we are here. Now again we have two paths. Either we can move towards this one or this one. First we will move to this. As the value is coming from the upper box, we add a gap in this sequence and align this gap with this base. So we are here now. Now we will align A and A like this. In this fashion, we will align the second path. Now the global alignment is completed, and it is used by many tools. Two famous tools are emboss needle and emboss stretcher. They use this global alignment. Thank you for watching. If you are new on channel, please subscribe the channel, hit the bell icon and stay connected for more learning.